From this vantage point, a lunar observatory bathed in the soft glow of Earthrise, our home planet seems both impossibly distant and intimately close. A pale blue dot cradled in the blackness of space, yet teeming with life and the echoes of billions of stories. For millennia we gazed up from that blue sphere, wondering about our place in the cosmic order. Now we stand on the precipice of a new era, one where we don't just observe the universe, we converse with it. The 22nd century dawned with a legacy of scientific breakthroughs, each pushing the boundaries of what we thought possible. Join me now as we embark on a journey through the frontiers of physics, a voyage that will take us from the heart of black holes to the edge of consciousness. This is the story of how we learned to dance with the universe, to compose symphonies of energy and matter, and to unlock the secrets of existence itself. For centuries, the greatest minds in physics grappled with a fundamental schism. Gravity, the architect of stars and galaxies, seemed to operate on a completely different set of rules than the quantum world, the realm of atoms and their constituent particles. Einstein himself spent his later years in pursuit of a unified theory, a single elegant framework that could account for both the cosmic and the microscopic. In the 21st century, the standard model of particle physics elegantly explained the interactions of all known forces and particles except for gravity. It stubbornly refused to fit into the quantum framework. The breakthrough came in the early 2040s with the discovery of the graviton, the theoretical particle that transmits the force of gravity. This elusive quantum messenger held the key to uniting the macroscopic and the microscopic, the celestial and the subatomic. Suddenly, we could peer into the heart of a black hole, not just as a gravitational sinkhole, but as a quantum object, potentially holding the secrets to the birth of the universe itself. We could manipulate gravity at the quantum level, opening up possibilities for new forms of energy, transportation, and even the manipulation of space-time itself. This unification of physics wasn't just an academic exercise, it was a revolution, a fundamental shift in our understanding of the universe and our place within it. The implications of this new understanding are still unfolding, but one thing is certain: the universe is far stranger and far more interconnected than we ever imagined. For millennia, gravity was the immutable backdrop of our existence. We built our structures to withstand it, launched our rockets to overcome it, but never to truly control it. The 22nd century changed all that. Armed with our understanding of the graviton and its quantum properties, we learned to manipulate the very fabric of space-time. Imagine cities that reach for the sky, not with steel and concrete, but with carefully calibrated gravitational fields that counteract the pull of the Earth. Imagine spacecraft that ride the curvature of space-time, gliding effortlessly between planets and stars without the need for cumbersome rockets or massive fuel reserves. This is the promise of gravitational engineering, a technology so profound that it borders on science fiction, and yet it is rapidly becoming our reality. We are already seeing its early applications in areas like high-speed transportation, where gravity manipulating trains whisk passengers across continents at unimaginable speeds. Imagine harnessing the power of black holes, not to destroy but to generate clean, limitless energy. Imagine manipulating gravity to deflect asteroids, to stabilize our climate, to reshape the very face of our planet. The challenge, as always, lies in wielding this power responsibly, ethically, and with a deep understanding of its potential consequences. In the 21st century, we marveled at the speed and interconnectedness of the internet. Information zipped across the globe in fractions of a second, connecting us in ways that were unimaginable just a few decades earlier. Yet, for all its wonders, the internet was built on a foundation of classical bits, fragile units of information vulnerable to interception and disruption. Enter the quantum internet, a network built on the principles of quantum entanglement. This bizarre phenomenon, once dubbed spooky action at a distance by Einstein himself, allows particles to share a connection so intimate that they influence each other instantaneously, regardless of the distance separating them. Imagine a network where information is not just transmitted, but teleported instantaneously and securely across vast cosmic distances. That is the promise of quantum communication. This isn't just about faster internet speeds or more secure transactions. It's about a fundamental shift in how we communicate, how we share information, and how we connect with each other. With quantum communication, we can establish real-time links with distant spacecraft, instantly transmit complex data from planetary probes, and even potentially communicate with hypothetical civilizations light years away. The possibilities are as limitless as the universe itself. Imagine telescopes linked together by quantum entanglement, creating a virtual observatory the size of the solar system, capable of probing the universe with unprecedented resolution. The quantum internet is not just an upgrade, it's a revolution in communication with the potential to reshape our understanding of the cosmos and our place within it. For centuries, we believed that gravity was the dominant force shaping the universe, pulling galaxies together in a cosmic dance. Then we discovered that the expansion of the universe was not slowing down as expected, but accelerating. Some unseen force was pushing everything apart. We called it dark energy. In the 21st century, dark energy was an enigma, a cosmic mystery that defied explanation. We knew it was there, we could measure its effects, but its true nature eluded us. Today, we're no longer just observing dark energy. We're learning to harness it. Imagine tapping into this vast, ubiquitous energy field that permeates the universe, a source of power so immense that it dwarfs anything we could ever hope to generate here on Earth. This is the holy grail of 22nd century physics, and the key may lie in understanding the very fabric of space-time itself. Early experiments suggest that dark energy is not uniformly distributed. There are subtle variations, ripples in the cosmic fabric that we can potentially manipulate. By creating localized distortions in space-time, we can potentially tap into the repulsive force of dark energy, using it to propel spacecraft to unimaginable speeds, or even to warp space-time itself, creating shortcuts across the vast cosmic ocean. Harnessing dark energy is not without its risks. The very nature of this force is still shrouded in mystery, and tampering with the fabric of space-time could have unforeseen consequences. Time, the relentless river flowing ever forward. For centuries, it was the one constant we could all agree on. Time marched on, indifferent to our hopes, dreams, and desires. We were passengers on its current, swept along by its inexorable flow. But what if time is not the rigid, unchanging entity we once believed it to be? What if, like light itself, time could be bent, stretched, and even perhaps reversed? This is the radical proposition of chronophysics, the study of time, not as a passive observer, but as an active participant in the cosmic dance. At the quantum level, time becomes a much more fluid concept. Particles flicker in and out of existence, their past and future states entangled in a haze of probabilities. The very act of observation, it seems, influences the flow of time at this subatomic scale. Imagine manipulating the flow of time around a spacecraft, creating a temporal bubble where time moves differently than it does in the outside universe. Imagine slowing down time to study fleeting subatomic phenomena, or even perhaps traveling through time itself. The study of time is still in its infancy, but the discoveries we're making are already challenging our most fundamental assumptions about the nature of reality. We are creatures of three dimensions, bound by length, width, and height. Our senses are tuned to this spatial reality, our brains wired to navigate its familiar constraints. But what if our universe is but a sliver of a much grander, multi-dimensional reality? String theory, a leading contender for a theory of everything, suggests that our universe may have as many as 11 dimensions, most of them curled up and hidden from our perception. These extra dimensions, far from being a mathematical curiosity, could hold the key to understanding the fundamental nature of gravity, the unification of forces, and even the existence of parallel universes. Using powerful quantum computers, we can create synthetic dimensions, virtual realms where the laws of physics operate differently than they do in our three-dimensional world. Imagine conducting experiments in a five-dimensional space where gravity behaves in unexpected ways, or simulating the conditions of the early universe in a 10-dimensional reality. The study of synthetic dimensions is still in its infancy, but it has the potential to revolutionize our understanding of physics, cosmology, and even the nature of consciousness itself. The idea that the mind can influence matter has been a staple of mythology and science fiction for centuries. Telekinesis, telepathy, the power of thought to shape reality. These concepts have captivated our imaginations, even as they eluded scientific explanation. But what if the barrier between mind and matter is not as impenetrable as we once believed? What if consciousness, far from being a mere byproduct of brain activity, is a fundamental aspect of the universe, intertwined with the very fabric of reality? Quantum mechanics, with its emphasis on observation and measurement, has opened up new avenues for exploring the mind-matter connection. The act of observation, it seems, is not a passive one. It fundamentally alters the state of the system being observed. If the act of observation can influence the behavior of photons, could it be that our thoughts, our intentions can also have a subtle influence on the world around us? We are still a long way from fully understanding the mind-matter connection, but the journey itself is already pushing the boundaries of scientific inquiry, challenging us to reconsider our place in the universe and the true nature of reality itself. Physics was once about understanding the world. Now it helps us shape it, responsibly, beautifully, and with awe. The 22nd century is not about breaking the rules of the universe, it's about learning how to compose with them. We are no longer passive observers of the cosmic drama. We are choreographers, learning to dance with the fundamental forces of nature, to orchestrate the music of the spheres. The power we now wield is staggering, and it is our responsibility to use it wisely. For the universe is not just a collection of stars and galaxies, it is a canvas upon which we are invited to paint our dreams, to write our stories, and to compose the next chapter in the grand symphony of existence.